All right, so now we're looking at continuous functions. So a function f is continuous at input c if and only if the following three conditions are satisfied. So we have to have f of c existing. Okay, so if we have a graph at some point c, that has to be a point. So there's, for that input c, there's an output f of c. The limit of f of x as x approaches c exists. So that means the limit from the left is equal to the limit from the right, and that's equal to some L. And then the limit of f of x as x approaches c is equal to f of c. So whatever that, plug in that c value, you get out the f of c value out for the output. And so basically it exists here, and this is equal to that there. Okay, so the function is continuous in an open interval if those three conditions are met for every input value in the interval. Now, a function is continuous everywhere if it meets all three conditions for every possible input value, and those we refer to as continuous functions. Now, let's look at our thing we had before. We have that, hole here at the -1. We have the asymptote. This goes to -infinity. So is f continuous at x equals 6? Well, here's x equals 6, the vertical line. And remember, one of the key things is the limit from the left has to equal the limit from the right. And do we have that? Well, the limit from the right is equal to -1. The limit from the left is equal to -infinity. Those do not equal, and so no, it's not continuous. What about x equals 0? Well, we could start with the first thing, and does f of c exist? Well, f of c does not exist, and so right there, it's already thrown out. And so no, it doesn't exist. Whereas f of c does exist on that one, but the limit doesn't exist. Now this one, the limit exists because the limit from the left is equal to limit from the right, which is equal to -1. But we have no f of c there, okay? And so because of that, that doesn't have a continuous function. So those are two examples from the previous one, and that shows that there's no continuity or no continuous function here. Now, another key thing about continuous function is basically what you can do is you can draw something from the left to the right and never lift your pen. And so if we look here, if we consider this goes on forever that way, and it considers it goes on forever, we keep going up and we never lift our pen. So that really is continuous. And so we can also look at every point on here, no matter what the point is, the limit from the left is equal to the limit on the right. F of c exists, and the limit at whatever that c value is going to be what the f of c is equal to. So that one, it looks like it's perfect. It's a good continuous function. So yes, that is continuous. Now, what about this one? Well, if we just go by the thing, if you can lift your pen, then it's not continuous. Guess what? At that point there, boom, we have to lift our pen to get down to here and go here. But we can look at it at different ways. Well, does f of c exist? Well, yeah, it exists. It's right there. Does the limit exist? Is it equal? Well, not exactly, because the limit from the left at this x equals 4, the limit from the left is equal to, it looks like 18. The limit from the right looks to be about 12. Those are not equal, so this is not continuous. So you can use the lift your pencil function or pen function, and if you have to lift it to get to the next piece, then it's not continuous. Or you can look at those three key items. Does f of c exist? Does the limit of f of x exist for x approaching c? And does the limit of f of x as x approaches c equal to f of c? Okay, and so that gives us those two, yes and no. Well, what about these? Well, okay, here we have a nice thing, but there's that jump here. So f of c does not exist. So that one is not continuous. Okay, so we can say these are not continuous, all of them, and the reason why is because here f of c does not exist. Well, here f of c does not exist either, because it's a vertical asymptote. Now the limit, it goes up here and it approaches positive infinity. Here the limit up here goes and approaches positive infinity, but we never have the f of c, and that's the key in this case. It doesn't exist. Now what about this one? Well, f of c actually exists. It's right there. But now our limit, does it exist? Well, the limit from the left is equal to whatever that is, and it's different than the limit coming from the right, which is here. So the limits do not exist. And this is h of x. And we can say as x approaches c, and that does not exist. Okay. Now what about this one? Well, we have that little keyhole again. Now see, we have actually f of c. That does exist. So we can't say it's just f of c doesn't exist. And the thing is this goes down here, and we have the limit equaling the left and right. So we do have a limit here. But what happens is the limit of, I guess we're at f of x again, as x approaches c, that does not equal f of c. So this is not what this is equal to. So that limit of f of x does not equal f of c. So that's the key problem with that one. So, both of these have f of c does not exist. Here the limit does not exist. And here the limit of f of x as x approaches c does not equal f of c. So, each one of them had something different that it had a problem with, and so that was why they were not continuous. All right, so I'll start one more.